Bismillahirrahmanirrahim. Welcome to the third lecture of week 6 of Plant Maintenance mp4 26 elective course. In the last lecture we have started the maintenance of valve. Today we will continue the maintenance of valve and conclude it. We will in the last lecture we have gone through what is valve, different types of valve, see the video of different type of what is valve, ball valve, gate valve, butterfly valve. There is one additional picture. This is the view of the butterfly valve. As it is can be seen that butterfly valve, this is automatic butterfly valve. It means it is controlled by automatic and instrumentation system. Now in the last we have seen the glow valve, and we see the video of glow valve. Now this is basically a comparative chart of different types of valve showing the open and closed position. In the butterfly valve, as we have butterfly, so this is open and this is in closed position. Check valve, as the flow is coming from left to right, this is open position and this is closed position. Gate valve, in the gate valve we have a gate or disc. The gate and this will sit in this position. This is open position, this is closed position. Glow valve, in glow valve we have two changes in the pressure. There is a harsh pressure drop as compared to other valve, so the flow will come. There is one pressure drop, there is second pressure drop. On the glow valve we have a conical or sphere type disc, so the chances of erosion are less as compared to gate valve. That is the reason why gate valve is not used for partial open, partial closed position. Gate valve is used for fully open, fully closed position. In ball valve we have a ball. This is closed position, this is open position. Now troubleshooting. This is a basic troubleshooting chart of the valves. First of all, what is the problem? The cause, effects and solution. मसला, वजह, उसके असरात और उसका solution. Valve leaking or not sealing correctly. This is general maintenance chart. Maybe due to valve sealing or not sealing correctly, maybe due to wear. As we know, as the time passes on, the chances of wear and the wear will increase, or maybe due to wear, maybe due to the reason that you have selected the wrong valve for the wrong application. For example, we require valve for petroleum products. We have selected a valve for water, or the material is not compatible. Foreign material, maybe if there is no filtration system, or the filters or the strainer installed on the pump, on the line or on the supply system is not, if the strainer or the filter is not working properly, or the filter size is large, or the pore size in the filter is large, so the foreign material will come. Foreign material may include dust, dirt, debris, or any other thing. So when the valve, in the last picture you can see, if the foreign material or the other material is stuck here, so how the gate valve disc will seal properly? So the gate valve will stuck in this position, then there is leakage, or maybe due to corrosion may be due to several reasons. Wear, as the wear increases, so the gate valve disc, let's take an example of gate valve. The gate valve disc is actual position is this, but due to wear out the gate valve, this portion of the gate valve wear out. So when the gate valve will sit in closed position, the gate valve disc sit in closed position, so this portion remain open due to wear out. So the flow, the valve will not close properly or 100%, the flow will, there is some flow of the fluid. Flange or flange board failure. As we have flange installed, here. Now, if the flange is not properly tied or sealed, or the flange is, so there is leakage from here. This is a common cause in industry, that flange, there is a leakage from flange, maybe due to gasket failure, maybe due to bolt not properly sealed, maybe due to gasket material not compatible. So there are several different reasons. Now, where formatical affects contamination of other stream. What is the effect of contamination of other streams? Let's say the valve is installed on the suction of the tank, on the suction side of the tank, and from the back end there is a common line which is coming. On one side we have diesel, on one other side we have petrol. So if the valve is passing, so there is chances that the product, let's say take an example that the tank in the oil storage tank there is diesel. So on the oil storage there is diesel. The valve is installed on the suction side. If the valve is passing and from the back end side we have the common line, on one side we have diesel, on one side we have crude, so there is chances that the crude will go inside the tank, so the product will lose. That's why the latest standard said there must be at least 2 hindrances on the suction side or suction side. It means that there must be 2 valves installed on the suction side. On the suction side of tank, as we have seen in the last, as we have discussed in the last lecture, that NRV is installed, check valve is installed. Other than check valve, there must be 2 valves installed on the suction side of tank, so the chances of contamination decreases. Now, if the valve is leaking, so contamination of environment, because if the valve is leaking, so the product will spill out. Petrol, diesel, crude, jet fuel or any other fuel will leak out, and it will contaminate the soil as well as environment. So that is the main role of the maintenance department, to continuously do oiling, greasing, cleaning of the valve. Cleaning is also necessary, because as you can see here, there are threads. Let's say take an example that this valve is installed in a 83 or 100 acre area. So there are 100 of valves. Like in PSO, oil storage terminal in Port Qasim, there is 8 kilometer 12-inch pipeline. 8 kilometer 12-inch. So there is 100 of valves, approximately there are 400 or 500 valves installed in our locality, in our plant. 400 to 500 valves of different size, ranging from half inch to 48 inch dia. So there is 1 person, 2 person continuously, as we do not have the maintenance team, so we have the technicians. Technicians go do cleaning first of all. This is the main point, because if the threads have the dust and dirt, then when you open the handle, then there is chances that after some time the threads will damage. So first of all you have to clean these threads, clean the threads, then do greasing, oiling, and there is one common thing, or you can call jugaad. As we have seen, the packing of the flour, atta or rice, this packing is very useful in industry, because we normally wrap the packing or wrap other cloth on this portion so that dust and dirt will not come here. Okay, and this is necessary that it is not available that all the valves can be maintained when required, because valves cannot be operated without prior permission, without having permission from operation department. Because let's say, take an example, if you open the valve, this is operation, so valve cannot be operated without the permission from the operation department. Now, so attempt to flush. What is the possible reason? That if there is contamination of the product, first of all attempt to flush, and the other solutions are tight the gasket, tight the nut bolt. If it is not possible, if it is if the problem not solved, then change the gasket. We will see in the videos later on in this lecture how to change, how to tight the gasket, how to tight the gland. So this is common problem in the industry. Valve not operating correctly, ball and whatever, corrosion of internal parts, foreign material, corrosion of handle. So the facts will be valve not sealing properly. If the ball is corroded or the ball is eroded, then there is chances that it will not operate correctly. Now see some general videos of valve maintenance.
Valves, like many other components, require some routine maintenance and are susceptible to mechanical problems. In this part of the program, we're going to take a look at one type of valve problem, a leak. Then we'll look at a routine maintenance task that an operator may have to perform to keep valves operating properly. If a valve's packing becomes worn or one type of valve, we'll look at a routine maintenance.
Now what is this guy doing? This guy is pouring the grease. This is simply a grease gun. As I have said in the lecture that greasing and oiling are necessary. So this guy is greasing the valve. You can see in each of the instrument, motor, pump, and there are some points pouring, point of the grease or oil. So this guy is this is a grease gun, manual handling grease gun, and this guy is pouring the grease in the valve.
Maintenance task that an operator may have to perform to keep valves operating properly. If a valve's packing becomes worn or fails completely, fluid will leak out around the stem. This type of leak is commonly referred to as a packing leak. In most valves, the packing can be adjusted to stop minor packing leaks. Packing is adjusted by alternately tightening the packing gland nuts.
This is basically a gland nut. As this guy is saying that in industry there is common practice to tighten the gland nut, or after some time you have to change the packing in this packing inside below the gland. So you have to, but do not over tight the gland, it will damage the gland.
Usually a quarter turn each at a time. This ensures that the packing gland doesn't become cocked in the stuffing box as the gland nuts are tightened. The packing is not the only place where a valve may leak. Another place is the joint where the bonnet of the valve attaches to
simple. This is the bonnet, this is the body.
The body. A leak in this area is commonly referred to as a body-to-bonnet leak. Still another place that valves can leak is where the body of the valve attaches to the piping system. On valve bodies with flanges, this leak is commonly called a flange leak.
This is a flange leak.
On valves that are attached to piping using methods other than flanged connections, this leak may simply be called a connection.
In flange leak, there is a common that maybe the gasket is damaged, or the gasket deteriorate, or you have tied the nut. You have tied the nut against, मतलब as आपने ज़्यादा tight कर दिया nut, तो उससे gasket में damage.
Leak. The final leak that we're going to look at, and one that is not so obvious, is an internal leak through a valve. As a valve disc and seat wear, fluid may begin to leak by the seat when the valve is fully closed. When this happens, the valve is said to be leaking through. This leak can be detected only by carefully observing plant instrumentation or conditions on both sides of the valve. Besides locating and identifying leaks, another task that an operator may have to perform is valve lubrication. Valves need lubrication to prevent components from wearing during operation. Each type of valve may require a different type of lubricant or method to apply the lubricant. For example, some valves have grease fittings and require the use of a grease gun to lubricate them, while other valves may have the lubricant.
This is a thread. This person is basically cleaning, and first of all clean the threads, then apply the grease.
And applied directly to a component such as this valve stem. Because there's so many different methods that may be used to apply lubricant, you should always check your company's procedures before lubricating a valve.
Hi, I'm Jerry Boots, Director of Engineering at Automation Service. I want to talk to you today about one simple way to extend the life of your control valve, and that's packing maintenance. Valve packing is a component in a valve that forms pressure seal between the inside of the valve and the outside of the valve, keeping the process fluid from leaking out. Over time, the packing will wear in, relax or loosen up with process temperature or even seasonal ambient temperatures and begin to leak. And any process fluid that leaks out of a valve can be costly, can be messy, and maybe even harmful to health and environment. The most important thing is to catch the packing leak early and address it before it has a chance to further cause damage. In the early stages of packing failure, it may be difficult to detect the process fluid coming out of the packing box unless you're very attentive and keeping an eye on the valve. But the leak is only going to worsen. Here we are at a typical valve location. I'm going to show you how to detect and correct a packing leak.
As it can be seen from this, there is a leakage of water or the liquid from the valve.
Here we see water weeping out around the packing and the valve stem. When you first notice this sort of leak, attempt to correct the packing leak by carefully tightening the packing nuts. I will use a 3/4 inch combination wrench and tighten the packing ever so slightly. It doesn't take much, just enough to seal the leak again. Be sure to tighten the nuts evenly and do not over tighten, or you could interfere with the actuator's ability to stroke the valve. When you see the leak has stopped, you've fixed it. Now if you find you have to use a fair amount of torque to tighten the packing nuts, you may be at the end of the adjustment and cannot tighten the packing any further. That means it's time to replace the packing set. Replacing the packing in the valve would typically involve removing the valve from service and disassembling the actuator from the valve, and then separating the valve bonnet and the body to completely access the packing box. Although this is a fairly easy task, you should refer to your product instruction manual for step-by-step directions.
This is the most important point, that if you are maintaining any valve, then first of all refer the instruction manual of the valve or the standard operating procedure for maintenance of the valve.
Or consult with your account representative with how we can take care of that for you. There are a multitude of other maintenance tasks that you can and should do with your control valves. But packing maintenance is probably the easiest and most cost-effective step you can take to extend the life of your control valve. If you do nothing else with the valve, keep the packing in good health.
Now we will see other videos as well. This is the second video of the globe valve. This is the body of the globe valve. What is this one? 200 mm. 200 mm divided by 25, because 1 inch is 25 mm. So this is a 8 18. 150 class, the flow direction is in this direction. Stem, disc nut. As it can see, it is in a conical shape. The disc is in the conical shape, but on the gate we have a gate. So you can see from this video that there is dozens of small parts of each valve. This is simply the video of the globe valve, gate valve, ball valve, check valve. So the maintenance of valve is not an easy task, especially when you have 400, 500 or 600 valve in a plant and you do not have the proper maintenance team. That's why maintenance is called a thankless job, because all the time the operation or the manufacturing department is saying that maintenance is not doing work. Now there is other three-way valve. We can see the video of this as well. This is three-way valve. You have seen this valve, gas, in power plant, water treatment bench, on which we have a control system, and there is three-way valve installed. There is no flow, there is straight flow. When we turn it, the flow is closed. So it is very helpful. Safety relief valve, pressure relief valve.
Relieves pressure more quickly than a relief valve. Their design and components are very similar. The direct acting safety valve is made up of a casing, inlet, outlet, disc, seat, spindle.
As you have seen in power plant stone vapor boiler, as you have seen in power plant stone vapor, that pressure relief valve is installed on the discharge side of pump, so that if there is excess pressure, then it can
cap. The safety valve assembly is protected by the casing, which is threaded or flanged for connection to the system. A cap covers the top of the disc is held in place until the system pressure increases to the point when the disc changes over a period of time. Certified personnel will reset the adjusting screw. The popping open of the safety valve surface of the disc is not exposed. What makes this to press against? This large area makes for a larger lifting force and causes the valve in reverse. Can damage the surface, also prevented by a small cushion. The opposite, rapid closure of the valve, the popping pressure is 200 psi and the positive seating pressure is 190 psi. The blowdown is 10 psi.
No, there is an important one thing to keep in mind, that normally, as I have said in my lecture, that the valves are ranging from ½ inch or 1 inch to 48 inch, 15. So as the size of the valve increases, the force required to open the valve increases. So normally for bigger valves, 20 inch, 24 inch, it is helpful that the valve must be automatically opened, or instrumentation and control system must be stored. So there is motor stored on it. We can have push on and off button so that we can open or close it for ease of maintenance. Now the last topic of valve maintenance is the valve testing. Well, there are different type of valve testing method. For details, you can see the API standard 598 valve inspection and testing. In valve testing, a typical hydrostatic valve test follow these steps. First of all, the valve, this is similar to the boiler hydrostatic testing procedure as you have learned in the power plant engineering. First of all, the valve body is filled with a testing fluid at the specified temperature. Testing fluid means if you are using the valve for water, use water, or if you have to install the valves on petroleum product, then use petrol at the specified temperature. We can see we have the video as well, but the video will be of not the hydrostatic testing, but it has air testing. The specified pressure is applied for the specified length of time, usually at least 1 minute. First of all, fill the fluid, then apply the specified pressure. Let's say the valve is designed for 200 psi, then the testing pressure is 1.5 times the design pressure. So we have to apply the pressure 300 psi and retain it for 1 minute. Now after 1 minute, check the leakage across the different elements, leakage across the valve, visual inspection as well. If there is no leakage, there is okay. Most valves specify that no visual detectable leakage is allowed. No visual leakage should be allowed. A visual inspection is performed to ensure the valve has not been damaged during the testing process. Now, first of all, fill the fluid, apply the pressure, retain it for 1 minute, check the leakage across different elements. Then, if there is no leakage, visually leakage, then it is okay. After the test, open the valve, check it, because there is chances that due to applying pressure there may be a crack or another thing. So we can see the video of the testing. Now this is simply a gate valve. The pressure gauge is installed here. This is flange connection on right side, black as the black metal piece. This is flange connection. This is also another flange. This test is applied using not the water, using air. We have learned in the water. Similar procedure can be applied for water as well. First of all, we close the flange. Then we started applying the air pressure. As this is showing the air pressure, they open the valve and now the air pressure is applied. What is the purpose of this valve? This valve is used to remove the air from, first of all, this valve is open so that air can go out from the system. Then this valve is closed. Now we started applying the air pressure. This is a timer because time is necessary for the testing. They have started the stopwatch from 1 minute and it is moving towards 0. This is the pressure, because the pressure must be 0 here, because if there is leakage the pressure will increase on the discharge side. Now this is a valve, cast iron body valve size 6 inch or 8 inch model. This is connection. These details are written on the valve. (26, 25). Pressure is applying 2.3 bar, approximately 3.5 bar. There is no pressure. Increase on discharge, it means there is no leakage. Now that's this today lecture. If you have any question you can ask on the live session.